Alrighty, awesome. So now that it's 8 o'clock, let's go ahead and get started on our final class in the AMC8 AMC10 workshop. I hope you guys are really excited. We've got a lot of really cool problems for this week, and this is kind of going to be a good wrap up and review of kind of all the concepts we've talked about. And we're going to introduce some new things, but generally lots of problem solving all around. So it's going to be really great. But before we get started, go ahead and answer our icebreaker for today, which is what is your favorite book or movie? Awesome. Okay, Adik says his favorite book is the Mathly Number Sense book. That's a pretty crazy pick, but also kind of valid. That's cool. That's cool. Ayush says Die Hard. Yeah, that's a good movie. There is always that debate about whether it's a Christmas movie or not. Um, So yeah, that's something interesting. I don't think it's a Christmas movie, but let's see. Manit says Big Nate. I've definitely heard of this, but I think it's like beyond my time. Let's see. Big Nate. Oh, no, this just kidding. This is when I was in middle school. Okay. DG says City Spies. That's one that I haven't heard of, actually. That's one I haven't read before. Very interesting. Manny says Harry Potter. Yeah, Harry Potter is really good. That's like a good canon book. I feel like even though it's super duper old, everyone should read it. Because it's good literature, even though it's like basic plot, but good literature, easy to follow, and you learn a lot. So yeah, Harry Potter, if you haven't read it, go read it. Rohan says the Minecraft movie. Wow, I'm gonna have to strongly disagree with that, Rohan. I think I just can't appreciate it because I'm not a big Minecraft player, but if you're into Minecraft, I heard that it was pretty decent. Awesome. Zombie says Harry Potter. Yeah, Ditya says Percy Jackson. Yes. So kind of like the counterpart to Harry Potter, I recommend reading both series. I actually never read Percy Jackson. I just didn't get around to it when I was younger, and then when I got older, I was just like, yeah, it's like too young for me, so I'm not gonna read it. But I would also recommend you guys read that too. It focuses a little more on mythology, rather than fantasy. So if you're into that, that's cool. Let's see. Sachi also says Percy Jackson and Harry Potter. Good. Sanvi says Percy Jackson. Sure says Harry Potter. Happy Potter. Or Percy Jackson. Awesome. Yes, those are both really good series. And it's good to see that you guys are still reading these kinds of things. I thought like maybe there are other books or maybe more popular things, but it's good to see that these really typical and old books have kind of lasted. That's good. And he says he's gonna read it tomorrow. That's awesome. Yeah, that's cool. I would say, I don't know. I don't really have a favorite book series. I read a lot, so I enjoy a lot of books, and I don't think I could pick one favorite one. But for favorite movie, I would definitely have to go with 10 Things I Hate About You. It's an old 90s rom-com, so if you're into that kind of genre, it's probably one of my favorites, hands down. But I really enjoy it a lot. It's really funny. Yeah. Anyone have any other favorite books or movies that they want to share? Oh, Anik says his favorite movie is Doctor Strange. Yes, the Marvel Universe is really good. And Benedict Cumberbatch, the actor who plays Doctor Strange, he's very good. He is an excellent actor, but that's a good one. Shrini says the Harry Potter series. Yep, yep. That's a classic. Awesome. Anyone else? Any other favorites that we can talk about? Oh, okay, awesome. Well, on that note, let's go ahead and get into our last class's content. I will say after this class is over, we'll send you kind of like a quick feedback sheet, just to see how you guys felt about the class, anything we can do better, and then also what kind of courses you'd like to see going forward. But anyways, that comes afterwards, so you'll get an email about that, or your parents will. Alrighty. On that note, let's go ahead and get into our first warm-up problem, which is from an old contest. I don't know if you guys have heard of this one, but it's pretty competitive, pretty difficult. It's called Purple Comet. Awesome. So basically what we have is we have two different equations, 2a plus 2 and 2b plus 2, both add up to 2004. And we want to find the sum of the numbers a over 2 minus 2 and b over 2 minus 2. So I give you guys maybe 30 seconds to think about this, and then we'll move on. Okay, awesome. So I see answers from Shrish and Manit, 496. I also see an answer from Ayush of 500. Shrini also put in 496. Okay, awesome. So these are our potential answers. Let's see which one is correct. So to start off, let's just translate the words into math. We have 2a plus 2 plus 2b plus 2 is equal to 2004. So that means that 2a plus 2b, we want to get the variables on one side and then the constants on the other, is equal to 2004. And then remember, 2 plus 2 is 4, so we're subtracting 4 here. So that means a plus b is equal to 1000. And the reason why we were able to do that is because this simplifies to 2000, and then we divide both sides by 2. But then we're trying to find the sum a over 2 minus 2 plus b over 2 minus 2. And this is just equal to a plus b divided by 2 minus 4. Well, we know that a plus b equals 1000, and actually that kind of looks like 7000. Let's fix that. Okay, there we go. A plus b is equal to 1000, so if we go ahead and divide this by 2, we'll find that a plus b divided by 2 is equal to 500. But remember, we want to find a plus b over 2 divided by 4, or minus 4. So this is 500 minus 4, or 496, which is the final answer. So to those of y'all that said 496, great job. And if you didn't get 496, review the solution, see where you were off. And if you have questions, feel free to put it in the chat, raise your hand, or DM. Okay, awesome. I don't see anything just yet, so let's go ahead and move on to our next warm-up question. All right, so in this question, it's from the same contest except a year earlier, so maybe it'll be a little easier. We will see. But in this one, we are dealing with three numbers, and we have relationships between all three. And we want to find ABC plus 1 over ABC. This one might take a little longer, but I'll give you guys maybe like another 30 seconds to think about an approach, and then we'll talk about it together. Alrighty, let's take a look. So this is kind of confusing, or it's not confusing, but it seems intimidating because we have three variables, and every equation we have only relates two of the variables together. So this seems kind of weird, but we can kind of get a product of three variables if we go ahead and multiply these three equations together. The reason why I say multiply is because we're looking at products, and I can immediately see if I multiply all three equations, I can get an ABC term, which is at least half of what I want. Sure, there may be some extra unnecessary terms, but I'm already one step closer to getting that ABC term that I want. So let's go ahead and multiply all three of these equations together. And I'm going to first try to find out how we can get ABC plus 1 over ABC by using these equations and then just substitute where needed at the end. So if we go ahead and multiply these together, I'm going to first multiply A plus 1 over B times B plus 1 over C. And this comes out to be AB plus A over C plus 1 plus 1 over BC. All right, I'm going to pause here, make sure you guys are clear on that. This is a little bit of binomial expansion, so if you need to take a second and review that, go ahead. Okay, awesome. So then the next one, so then we have to multiply AB plus A over C plus 1 over BC by the last equation, which is C plus 1 over A. So I'm going to multiply C by everything in this first part, and then I'm going to add that with 1 over A multiplied everything in the second part. So starting off, we'll have ABC plus A plus C plus 1 over B plus B plus 1 over C plus 1 over A plus 1 over A, B, C. Okay, so I'll show you guys which part is which. So this first part over here is going to be C multiplied by the 4 terms. And then the second part over here is going to be A multiplied by all these terms. So take a second, make sure you see where this entire expression is coming from. And if you guys have questions on how we expanded or did any of that multiplication, feel free to go ahead and put it in the chat. Okay, I don't see any questions. Oh, can I recap? Yes, cool. So to kind of begin, what we're doing here is we're multiplying all 3 of our expressions together because we're trying to find the sum of like 2 different products. We're trying to find ABC plus 1 over ABC. So even though it may not seem like this is going to immediately simplify to this product over here, that's okay because I can see that if we multiply each of these expressions together, there's going to be at least one term that is A times B times C, which is at least one step closer to what we want. So that's kind of our motivation for going into the multiplication. So to multiply, what I first did was I multiplied this first term and the second term. Because I think it's easier than multiplying all 3 at once. When you multiply those 2 together, you'll get this product in red. And then we went ahead and multiplied the red product by this yellowish brownish product, C plus 1 over A. And then when you do that, that's just simple distributive property. The part underlined in green is C multiplied by the 4 terms, and the part underlined in blue is 1 over A multiplied by the 4 terms. So then we add those up together, and this final answer on the right-hand side is going to be the expansion of this product. Okay, awesome. And I am seeing some answers from people of 750 and 777, so we will see if that is what we end up getting. Okay, awesome. So now that we have this, well, I do see a couple of the terms we want. I do see an ABC term, and I see a 1 over ABC term. But then there's also a lot of excess terms. I see A, C, and B, and 1 over A, 1 over B, 1 over C. But what's really nice is that all of these terms are actually in the original equation. We already have values for all of those terms. For example, we know what A plus 1 over B is, we know what B plus 1 over C is, and we know what C plus 1 over A is. We know all of these values already. So what we can do is we know that ABC plus 1 over ABC plus A plus 1 over B plus B plus 1 over C plus C plus 1 over A is equal to, remember how we even got this expression in the first place? We multiplied each of these 3 values together. So this is equal to 5 times 12 times 13. But because we want to find just ABC plus 1 over ABC, this is going to be equal to 5 times 12 times 13 minus A plus 1 over B, which is 5, minus B plus 1 over C, which is 12, minus C plus 1 over A, which is 13. So if we go ahead and expand, 5 times 12 times 13 is equal to 60 times 13. I did 5 times 12 to get 60. And then minus 5 and 12 and 13. I can just add those all up together and then subtract as a sum. So that's going to be minus 30. And then 60 times 13 is equal to 780. So then if I go ahead and subtract that 30, I get a final answer of 750. So those of y'all that said 750, that is absolutely the correct answer. All right, so I'm going to pause here and kind of pause for questions really quick. So if you guys want me to recap how we did this last bit of arithmetic, I can totally do that. But the main idea in this question was trying to manipulate these equations to get into the form that we wanted them to. All right, awesome. I don't see any questions, so let's go ahead and move on to the next one, which, believe it or not, is also from the same contest set, Purple Comet. I don't know if you guys still do Purple Comet these days, but I think I did them like way, 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 way back when I was in middle school. Um, but yeah, okay. So now I want to find the prime number p for which p plus 2 and 2,500 is a perfect square. All right. I see some people putting in 101, and I also see a couple people putting in 100. So let's go ahead, take a look at what is correct. But first, let me write down these potential answers. Oh, yes, good catch. 100 is actually not prime, so that can't even be a possible answer. Good catch, good catch. Okay, so let's let p plus 2,500 equal x squared. So if we go ahead and rearrange this, solving for p, we'll get that p is equal to x squared minus 2,500. But remember that 2,500 is actually just 50 squared. So we can say that p, actually, let me do this horizontally. Okay, p is equal to x squared minus 50 squared. And if you've been with us in our previous classes, or if you've ever done a little bit of algebra, I'm sure you guys can all recognize this immediately as difference of two squares. So the factorization when we're subtracting two squares is x minus 50 times x plus 50. Okay, so now that we have this factorization, the only way that this can be prime is if one of these terms is equal to 1. That's the only way this can happen. Otherwise, you'll have one term be even and one term be odd, and then you just get crazy mess. So, or actually, it's not because it's even or odd, it's because remember, by definition, prime numbers have exactly two factors. So if suddenly I have like a 3 and like a 53 over here or something, like that's not gonna work out because that means that I have more than two factors. So the only way that I can have two factors is if one of the factors is prime and the other is the number itself. So because x is positive, x has to be positive, we're going to say that x minus 50 is equal to 1, which means that x is equal to 51. Then we have that p is equal to 51 minus 50 times 51 plus 50. And 51 plus 50 is 101, which is the final answer, as many of you guys said before. Alrighty, awesome. I think the important part of this question is the factorization and then being able to recognize the only possible value for the factors. Kind of to recap once again, the reason why we can't have the factor be anything except for 1 is because if we have it as like not 1, then you're introducing other factors. But remember, prime numbers have only two factors, 1 and itself. So that means one of these numbers has to be 1. Okay, awesome. Any questions here? Okay, I don't see any questions, so let's go ahead and move into our main content for the day, which is going to be a little bit of work with absolute values. Um, So absolute values do come up quite a bit, and recently they are making up some of the more complex problems on exams. And if you guys start taking the AMC10, you will definitely see a lot of abstract value problems. So being able to master this is really, really important. Um, so to start off, the absolute value is kind of like a function. It is a function, and the reason why that is because it represents the distance of a number from zero. Now, you probably haven't heard of that definition before if you've worked with absolute values. Most people will just tell you, oh, an absolute value makes something positive. But I think it's more important for you guys to remember that an absolute value is the distance from zero. And the reason why that is because you'll kind of be working with this absolute value concept beyond just algebra. If you take other courses involving like vectors and things, you're definitely going to see absolute value in a different form come up. So in general, remember, if you ever see absolute value, it is the distance from zero. Now, because we're working with just integers, it's going to be the distance from zero on the number line. So this distance is always a non-negative value. Remember, negative distance is not a thing, doesn't make sense. So that means if we have the absolute value of -5, we represent that with two bars surrounding the value. The absolute value of -5 is equal to 5. Notice how this is a non-negative value because that's the distance from 0 to -5. It's 5. Okay, and similarly, the distance of 5 from 0 is just 5. So the absolute value of any positive integer is going to be the number itself. Okay, awesome. Let's see. Okay, so in general, and this is what you probably hear, if x is greater than or equal to 0, meaning if it's non-negative, then we'll say that the absolute value of x is just equal to x. However, if x is negative, meaning it's less than 0, then the absolute value of x is equal to -x. And this kind of definition, this kind of notation we're using here is actually very crude and basic level piecewise functions. So formally, someone would write this as like f of x is equal to, and then they'll do like kind of like these semicolons, and then they'll kind of just denote it like this. So this is how we do piecewise functions, which also come up a ton. And absolute value is a great definition of a piecewise function. And yeah, this is something that there's a lot of work on. I did a little bit of work with these in my last semester of math, so it's very interesting. There's definitely a lot going on here. But kind of moving away from that, let's go ahead and kind of look at graphs. Absolute functions, I feel like a lot of people constrain absolute value to kind of just algebra and doing a lot of casework and things. But what a lot of absolute value functions and a lot of absolute value problems can actually be solved with graphs. And the reason why that is because the graph is very nice and very symmetric. So let's take a look. And actually, instead of giving you guys the graph, let's go ahead and graph this ourselves. So to start off, I am going to, oh no. Okay, so to start off, let's go ahead and draw a coordinate grid. So we have our y-axis up here. Oh, it looks like my tablet is not working right now. Well, it's okay, we'll fix that. For now, I'll just write with my mouse. All right, so we have our y-axis and we have our x-axis. So let's say we start at the point 0. Let me know in the chat, what is the absolute value of 0? Yeah, it's just 0. And remember, the distance from 0 to 0 is just 0. It's at the same place. But we also can use this definition up here. Because we're satisfying the fact that 0 is greater than or equal to 0, that means the absolute value of 0 is just itself. So that's going to be 1 point right here. All right, now let's go to the point 1, which is over here. What is the absolute value of 1? Yeah, it's just 1, which we'll graph over here. All right, what's the absolute value of 2? Yep, just 2. And what about for 3? Yep, just 3. Okay, cool. I think you guys can see where this is going. All right, so let's go on to the other side of the axis. What about when x is -1? What's the absolute value? Okay, it's 1. What about when x is -2? What's the absolute value then? 2. Very good. What about when it's -3? 3. Okay, and I think you guys can see where this is going. So if we go ahead and connect the dots, we get something that looks like this. So the absolute value function is actually two lines kind of going towards each other and stopping at the origin. Notice how there's like the absolute value function never goes below the y-axis. And the reason why that is because remember the definition of absolute value. It's the distance from 0 to a number. And because the distance always has to be positive, that means the y value is always positive and we never let the function go below the y-axis. Yeah, it'll never be negative. That's absolutely correct. Okay, awesome. So if you guys want to see a prettier graph with actually nice grid lines, I'll go ahead and paste one for you. Whoops. Oh, okay, just kidding. I won't paste one for you because I'm having technical difficulties. Anyways, on that note, let's go ahead and take a look at a quick question, making sure that we all understand the definition of a absolute value. So go ahead and solve the equation 2x, the absolute value of 2x minus 5 equals 11. Take a couple seconds to solve that, and then we'll discuss the solution. All right, I see a couple answers for x is equal to, oops, I meant to change colors there, 8, and x is equal to -3. Great, let's see if that's right. So to start off, like I briefly mentioned this earlier, but I said that a lot of absolute value problems kind of tend to boil down to casework. And the reason why that is because when we're working with absolute value, we have to consider the case when the value or kind of the expression inside the absolute value signs is positive and whether or not it's negative. So let's say case 1. 2x minus 5 is positive or non-negative, so greater than or equal to 0. So that means that the absolute value of it is just going to be 2x minus 5, which is equal to 11. So that means that 2x is equal to 16 and x is equal to 8. All right, so I see where you guys are getting x is equal to 8 from. That looks pretty good. Let's now take a look at case 2. But first, I need to make some space. Oh, that's not what I wanted to do at all. All right, there we go. All right, so for case 2, we're going to say that 2x minus 5, that expression, is negative, meaning that it's less than 0. So that means that 2x minus 5 is equal to -11. So that means that 2x is equal to -6 and x is equal to -3. And so that's where you guys are getting your second solution from. So the solution to the absolute value of 2x minus 5 equals 11 is just 8 and -3. All right, pretty good, pretty simple question, pretty good knowledge check. The important part is making sure you guys get both solutions because both are solutions to this absolute value. Okay, awesome. Let me know in the chat if you guys understand what we did here, or if there is any part of the logic that seemed kind of weird. Okay, smiley faces. Oh, and actually, this is something I forgot to mention. Yesterday, in yesterday's counting and probability class, we started doing like smiley faces whenever people were good on a topic or like excited about something. So if you guys want to do that, you are so welcome to. If you ever want to put a smiley face in the chat because you just really understand what's going on, that would be really cool. Okay, awesome. Happy to see smiley faces from Anit and Aditya. That's really great. Alrighty. And also Shrish. Thanks, guys. Okay, let's take a look at another question. All right, so now we want to find, oh dear. Okay, now we want to find kind of something a little different. Not super tricky, but definitely different. What is the value of x if the absolute value of x minus 1 is equal to the absolute value of x minus 2? All right, I see a lot of people saying 1.5. So let's go ahead and take a look at this question. Remember that for this one, people will do this in different ways. Some people will maybe graph the question. Some people will maybe do a little bit of casework. I think we should use the definition of an absolute value. Remember, in this case, the absolute value of x minus 1 represents the distance between x and 1. And similarly, absolute value x minus 2 is the distance between x and 2. So what we're saying here is that these two distances are equal. That means that x is equidistant from 1 and 2. So the number that's in the midpoint of 1 and 2 is just 1 plus 2 divided by 2. It's the average of the two numbers. And that comes out to be 3 over 2 or 1.5, like many of you guys said in chat. So that is absolutely the right way. I am sure some of you guys maybe did a more algebraic approach, which is totally cool. I'm going to illustrate the geometric approach because I think it's worth seeing what these different absolute value functions look like. So let me clear up the solution. All right, so like we do anytime we graph equations, we need to graph each equation separately and then see where they intersect, because the point where they intersect is going to be their solution. So starting off, I can draw. Okay, there we go. This is the y-axis, this is the x-axis. I feel like let's change colors. So let's do light green. So the absolute value of x minus 1. Remember, we said that the absolute value of anything is just going to look actually, no, let's not do it like that. Let's just go case by case. So let's say that x is equal to 0. What is the absolute value of x minus 1? Feel free to put your answers in the chat. Yeah, it's just 1. Okay, perfect. So that means that y is going to be equal to 1 up here. All right, what is the absolute value of x minus 1 when x is equal to 1? Yes, it's 0. So we're going to go over here. What about when x is equal to 2? Yes, it's going to be 1 again. And then what about when x is equal to 3? It's going to be 2. Very good. What about when x is equal to -1? Yeah, still 2. Okay. And you can probably see where the graph is going now. So let's go ahead and draw that really quick. So this is the absolute value of x minus 1. For reference, remember the absolute value of x is this graph. Well, okay, hold on. I didn't draw the slopes exactly right, so let's fix that so it's a little more clear. Okay, so this is the absolute value of x. And as you can see, the v parts are kind of parallel. This line is parallel to this line, and this line is parallel to this line. The only thing that's changing is that x minus 1, the absolute value, is shifted over 1 unit. So based on that observation, what do you think the graph of the absolute value of x minus 2 would look like? Describe it like as best as you can in words. I know obviously you guys can't send me drawings or whatever. Yeah, it's shifted 1 more unit than x minus 1. So if we go ahead and draw that, I don't know, what color should I use? We'll do a red. I feel like it's easy to see intersections between green and red. So that means I'm starting here, and then I'm kind of just continuing in the same slope, like that. And like this. So this is the absolute value of x minus 2. And like I said before, remember the solution to this equation is where these 2 points, or these 2 equations, intersect. So if we look at where, I know we have a lot of lines and a lot of colors, but remember we're trying to see where the red and green functions intersect, and that's going to be at this point right here. And I know obviously you can't tell very well from the graph, but you can kind of see that this is 1 unit, and this is the second unit, and this is right in between. So maybe you have to do a little algebra, or maybe you just have really great intuition and really great drawing skills, so you can tell that that's 3/2. But this is a good check to see that our answer is within the right bounds. And it's also good to see how these functions look graphed out. So in case you guys haven't studied like function transformations or whatever, this is kind of a good intro into that. So notice in this case, we're changing the argument of the function. The argument is what kind of goes inside of the function. So this is the argument. And this is changing from just having a normal x argument. So when you change the argument or the value that goes inside of the function itself, then what you're doing is you're shifting your value to the right or to the left. In this case, because we decreased all x values by 1, we're going to shift to the right, which seems kind of backward and intuitive, but that's just how the graphs work out. And then similarly, if instead I had done something like the absolute value of x, plus 1, in this case, I'm not changing the argument itself. My argument is still just x. Instead, what I'm changing is stuff outside of that. So that means my y value is going to go up or down. So this is kind of like a very, very basic introduction to function transformations, which you'll probably study a lot more, I believe, if you're in 8th grade. They do teach that in the content curriculum, I think. But this is a good intro, and it's pretty easy to see how each of the changes are reflected in the graph itself. Alrighty, so on that note, now that we've kind of looked at absolute value functions with different arguments, let's go ahead and take a look at a much more complex problem, but definitely solvable with the tools we've talked about so far. Alrighty. So we want to find the ordered pair of real numbers x comma y, which satisfies the equation this mess. So I will give you guys like 45 seconds to think about it, and then we'll kind of go into an approach and see if that helps anyone a little bit. All right, it seems like we've already got an answer from Shrish of -1/8, maybe. And Manit says 1/0. Awesome. Let me change my pen color though. I feel like we can do orange again. -1/8, 1/0. Cool. Any other answers? All right, let's go into the solution. So I said this problem is pretty tricky, and you're probably thinking of all the ways you can solve it. Maybe you want to do some algebra, maybe you want to do some graphing, but let's hear from Shrish about how he did this question since he got an answer pretty quick.
So basically what I did was I realized that both of these equations have to be 0 because neither one of them could be negative. So if you could add both of the equations to cancel out the y variable, and you would get 5x plus 5 is equal to 0, and that would mean x is equal to -1. And if you plug that into the first or second equation, you get y is equal to 8.
Wow. Okay, that's really clever. So kind of to explain Shrish's solution here, which is really the key to solving this problem. The rest of the steps you guys already are experts at. But what we know here is that absolute values, we talked about this before, always have to be non-negative. We can never have a negative absolute value term. Like that's just not possible. Because remember, the definition of absolute value, you've heard me say it 1,000 times, is the distance between the number itself and 0. So a distance can never be negative, it can only be non-negative. That means that in order for the sum to be 0, both of these terms have to be 0. If one term was positive, that means in order for the sum to be 0, the other one would have to be negative. So it's not possible to have one term be positive and one term be negative. Both have to be 0. That's the only way you'll meet the definition of distance being non-negative. Minnie, I see you have a question. You want to go ahead and ask?
So, like, can't it also be like -1, 0?
let's solve for the way here, and then we'll go back
Oh
and
wait,
check negative one,
I just
zero.
realized it's absolute value.
Okay, there you go. Cool. All right, awesome. Okay. So let's go ahead. Now that we know that each part has to be zero, we know that x plus y minus 7 is zero, and 4x minus y plus 12 is equal to zero. And you guys are in the AMC8, AMC12, or AMC10 class, so I'm sure you guys know how to solve these equations. Very, very obvious case of elimination. You have a plus y in one equation and a negative y in another. So let's go ahead and add these together. We will get that 5x plus 5 is equal to 0. That means that x is equal to negative 1. And because we have the value of x, let's go ahead and plug into this first equation because I think that's easiest. We have negative 1. Oops. Okay. Negative 1 plus y minus 7 is equal to 0, which means that y is equal to 8. So our final solution is x comma y, which is negative 1 comma 8. Alrighty, what do we think of this question? Let me know if you guys have any concerns, confusions. Otherwise, we'll go ahead and move on. You guys are really speeding through the content today, so we might end a little early. We will see. All right, looks like we're doing pretty good. Let's go ahead and take a look at our next question. All right, this one's probably a little easier. So that last one was tricky. You guys can definitely do this one. All right, give you guys like 30 seconds to think, and then we'll talk about the question. All right, it actually seems like we're getting some answers pretty quick, and a lot of people are saying the answer is 0. Very good. Okay. I think you guys are getting sick of me saying this, but remember, absolute values can never be negative. And what also can't be negative? Perfect squares. Perfect squares can't be negative until you enter the world, like the realm of imaginary numbers, which is like beyond the scope of this course, but you will definitely hear them. I believe I learned about them in 8th grade, so I think maybe that's when you guys will learn about them too. But anyways, the point of this is that absolute values are always, 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 always positive. So if this is positive, that means the negative of the absolute value has to be a negative number. But we know that perfect squares can't be negative, as DG said in the chat, which means that it's never possible for a squared to be a negative number. And if it's not possible, that means there are no solutions. Okay, very good. So that was pretty, yeah, that was easier than the previous question. And also, it wasn't a lot of math. It was thinking about definitions and kind of like bounds for what numbers can be. All right, awesome. So let's go ahead, and I think this is probably going to be one of the more insightful questions that we're going to do. There's going to be a lot to learn from this one. So go ahead, take a crack at it, and let me know if you guys get an answer. And then we will solve this together. I think there is a lot of properties in this question that are worth exploring. Um, okay, I see one question from Srini. What about the square root of negative 1? That is I, right? Yes, and that is what I was talking about. That is what we call imaginary numbers. So in this case, because the question kind of specified solutions, we typically only consider real solutions. If they specifically mention like complex or imaginary solutions, then we'll consider things like imaginary numbers. But otherwise, you kind of just assume we are talking about real solutions. And in this case, there are none. Alrighty, awesome. So let's take a look at this question, which is probably something you want to solve with some graphs because they're looking at area. And I'm gonna give you guys like another 15, maybe 20 seconds, and then we'll talk. Alrighty. Don't see any answers just yet. So I'll give you guys maybe like another 30 seconds and then we'll come back. All right, awesome. So what I'm going to do is I'm going to start drawing the diagram and hopefully this will give you guys a hint as to how we do this question. Let's do green axes. I feel like we always do blue. All right, seems like we got an answer from Shrish of 96. So we will see if that is correct. All right, so to start off, I first want to draw each of these graphs. So I need to set up my axes. Oh, I don't like that. Let's do here. All right, so y-axis, x-axis. So this is kind of weird. I'm looking at the sum of two different absolute values, and then I'm asked to graph it. And the weird part is that there's an x and a y, which is like, what is happening? But the way that I like to do these is look at different values for x and y, and then kind of just connect the dots from there. So let's look at the most extreme case possible. Let's say that y is equal to 0. What does x what can x be in that case? Yeah, I see answers from DG of -6 and 6. That's correct. Because when we have x is equal to -6, the absolute value of 2 times -6 is the absolute value of -12, which is 12, which is what we want. And then similarly, that means that 6 can also be a potential value of x. So when y is equal to 0, x can be equal to -6, which is here. No, that's 6. That's 6, 0. And then -6, which is over here. I don't know if you guys can see like these tiny lines that I'm drawing against, but like this is the scale. Okay, awesome. And then let's go to the other extreme case, which is when x is equal to 0. When x is equal to 0, what is the possible values of y? Yeah, -4 and 4. So this is going to be 0, 4. Or 4, 0, and then this is going to be 0, -4. Okay, awesome. So we kind of have like some decent bounds, but I still don't know what this looks like. Well, I don't know. Maybe we can hedge a guess. What shape do you guys think this graph is going to look like? What do you guys think? Okay, Manit says a triangle, but I see 4 points. How can we get a triangle from 4 points? Okay, I do see a couple of people saying rhombus as well. That's interesting. Yeah, I definitely think it's got to be some kind of quadrilateral because there's 4 points. Srini says a parallelogram, which is a more broad classification of rhombus. So let's go with parallelogram. I think that's the broadest we can go because a rhombus is pretty specific. Okay, so let's go ahead and remember because we're considering extremes, technically we don't have to find the other points in this problem. We know that these are the most extreme points. That means there is nothing beyond these bounds. Everything is contained within. So if we go ahead and connect, that's our graph. Which is definitely quadrilateral. And something interesting to note is that it is indeed a rhombus, and that's because all of these sides are congruent to each other. We'll come back on why that's true, but for now, let's get to the bottom of this question, which is finding the area inside the graph. So there's a couple of ways we can do this. One way is to look at, I see a lot of symmetry. So this is the way that is like calling to me. Exploit the symmetry. I see 4 triangles that are equivalent to each other. They're congruent. So I'm going to find the area of one triangle and then multiply by 4. So I know that because I'm going from the origin here up till 0, 4, this is going to have a height of 4 and similarly a base of 6. So the area of this one triangle is going to be 6 times 4 divided by 2, which is 12. And because I know that these other 3 triangles are congruent, these other triangles are also going to have an area of 12. So that means I have 4 triangles, each with an area of 12, which means that the total area of this rhombus is 12 times 4, or 48. Okay, amazing. So let's go back and talk about a couple of things. First, how do we know this is a rhombus? Well, remember the definition of a rhombus is one that has four sides all equal to each other and opposite angles congruent. In this case, we can see that all four sides are equal to each other. And honestly, that's enough to call it a rhombus. We can't call it a square, but we know that it's a rhombus because it's quadrilateral with four sides equivalent to each other. Um, and that kind of comes from the fact that like the triangles that make it up are also congruent. So I feel like it's pretty intuitive that this is a rhombus. Second, what are some other ways to find the area? Well, the approach that we took here was looking at the triangles in turn, but you can also look at the diagonals. And in general, if you're looking at the diagonals of a quadrilateral, the area of that is typically 1/2 of the product of the diagonals. So if I look here, I can see that one diagonal, the shorter one, has a length of 8. And the other one has a length of 6 plus 6 or 12. And then I take 1/2 of that, and that gives me my final answer of 48 once again. So that's another way to look at area, and I feel like this is a good way to kind of explore different area methods, just because it's pretty easy to see where this graph and where all the properties are coming from. Okay, amazing. One thing I want to clarify is that the graph itself is this green stuff around. There is nothing inside because remember we're dealing specifically with an equal to sign. If instead we had the absolute value of 2x plus the absolute value of 3y is less than or equal to 12, then you would color in everything on the inside because those points also satisfy that inequality. But because it's an equation, we only have like that border of a rhombus instead. Okay, cool. Let me pause here and see, does anyone have any questions about this problem? I will say the big idea, the big theme is being able to graph these things. This is something that we have not graphed before, but if you use general graphing techniques like looking at extreme points and then kind of using what you may know about absolute value functions, you can kind of get a pretty good graph from there. There was an AMC 10 question, yeah, AMC 10, a couple years ago, I think it was 2 years ago, that had absolute value. Like it was just an absolute value question, and the easiest way to solve it was by actually being able to graph. Otherwise, if you didn't graph and you did it algebraically, you would be sitting there and doing 16 cases by hand, which is really, really bad. You never want to do 16 different cases. So that's why being able to graph absolute value functions is really important. And they also have a lot of symmetry that you can exploit, which is why it is very nice to solve questions by graphing absolute value functions. Okay, amazing. I do see a question from Adarav about how did we get the 4 and the 6 again? I just forgot. Yeah. And I think Shrish answered this below. We kind of look at the extreme value for each variable. So the first extreme value I want to consider is when y is equal to 0. And when y is equal to 0, the absolute value of 2 times x has to be equal to 12. So that means that x is equal to 6 or negative 6. And then similarly, I look at the extreme case of when x is equal to 0, and that means that the absolute value of 3y is equal to 12. So that means that y is equal to plus or minus 4. And that's where we kind of get each of those extreme values from. Okay, awesome. All right, so that is all I have for you guys for tonight. And that's kind of the end of our AMC8, AMC10 problem solving session. If you guys want to see any other different classes or topics, feel free to message me, email me, and let me know because we want to make more classes for you guys about things that you want to learn. So please let me know. And also, good luck for you guys who are taking any competition series next year. I hope this class did help you. And yeah, feel free to keep in touch, update me on your progress, and hopefully we will see you soon in future Bridge to Math classes. All right, bye everyone. Thank you so much and have a great evening. Great, thank you. Bye.
Did he sign in as me?
Hmm?
Who's that?
This is me.
No,
That's you.
I left.
Oh, this is other you, I guess.
I guess Daddy signed.